Hello, my name is Taylor Talley, and today I'm speaking with Dr. Joe Candela. He served as a spokesperson on the CMS experiment at CERN during the discovery of the Higgs boson. Thank you very much for joining me. Thank you for having me. This is a project I'm very proud to talk about, not just because of the discovery itself, but because of the number of people, years of work, and critical science that went into it really played a big role in what I was wanting to do. So, thank you very much for having me here today. So, we have a few questions for you today. First, could you tell us your name and tell us a little bit about the project that you're working on? Well, my name is Joe Candela. I was a professor at the University of California at Santa Barbara. I served as the spokesperson for the CMS experiment at CERN. The project I was involved in was the search for the Higgs boson using the LHC, or the Large Hadron Collider. CMS stands for a compact muon solenoid, which was one of the major particle detectors at CERN. Our job was to study extremely high energy proton collisions and look for signs of particles that had never been directly observed before. So the Higgs boson was especially important because physicists had predicted it for decades, but no one had actually found it. So our project was not just about finding a new particle. It was about testing one of the most important ideals in modern physics. Perfect. Thank you for that. So with this, what exactly were you trying to find? Oh, we were trying to find evidence for the Higgs boson. The simple way to explain it is this. The Higgs boson is connected to the Higgs field, and that field helps explain why some fundamental particles have mass. Without that mechanism, the standard model of particle physics would be missing a major part of its explanation for how matter works. At the LHS, we accelerated protons close to the speed of light and collided them. The collisions created many particles, but most of them only existed for a fraction of a second before they would decay. We could just take a picture of the Higgs boson directly. Instead, we had to study what it had decayed into and look for a pattern in the data. In 2012, CMS and ATLAS both saw evidence for a new particle in the mass range of about 125 GeV. That was exactly the kind of region where a Higgs-like particle could appear. That's very interesting. Next, where did these experiments take place? Our experiment took place at CERN near Geneva, Switzerland. The collisions happened inside the LHC. The LHC is an underground circular particle accelerator. It's one of the largest and most powerful scientific instruments that's ever been built. CMS was one of two major experiments involved in this discovery. The other was ATLAS. What made the results so strong was that these two experiments worked independently. We had different detectors and different teams, but both experiments found evidence pointing to the same new particle. CERN later described in July that the announcement as the moment when ATLAS and CMS presented the Higgs boson discovery together. A lot going on in the world in 2012. So, what else was happening around the world when this discovery was made that you can recall, and maybe the impact that it had on the study? We had formally announced on July 4th in 2012. It happened during a period when science and technology were changing very quickly. Computing was becoming more powerful, and that mattered a lot for our work. The LHC produced enormous amounts of data, so this discovery depended not only on physics, but also on advanced computing, data storage, and communication levels that we had never seen before. Around this time, the world was also focused on major international events. It was an Olympic Games year. So in a broader sense, 2012 was a year when people were watching a lot of global achievements, especially in physics. With the discovery of the Higgs boson, it was a product of what can happen when a large number of scientists from all around the world work together for one common goal. Such a big project had an impact on a lot of different people. It couldn't have been done alone. Um, who else was involved in the Higgs boson project? Correct. This was not the work of one person, it involved thousands of people. The main experiment groups were the CMS Collaboration and Atlas. I represented the CMS, and Fabiola Gianotti represented Atlas. She and I both presented results at CERN on July 4th, 2012. There were also the theorists whose work made this research possible. Two of the most famous were Peter Higgs and Francescus Englert. They helped develop the theory behind the mechanism that predicted this particle. In 2013, they received the Nobel Prize in Physics after the discovery had confirmed that theoretical work. But beyond the names these people recognized, there were engineers, technicians, graduate students, software specialists, detector experts, accelerator operators, instrumentation divisions. So each of them are all in with a discovery like this one. It happens only when people do their parts correctly. Can you tell us a little bit about the role that you played in the project and maybe how you were chosen for this role? Right. Yes, I was the spokesperson for the CMS experiment. The title may sound like it only means public speaking, but in CMS it is much more than that. In one interview, I had explained that the spokesperson role is more like an executive leadership position for the experiment. It involves helping guide the collaboration, keeping the work organized, and then ultimately making sure the scientific results are presented responsibly. And during the Higgs search, my role was to represent the CMS collaboration and help communicate the results. That was, one, being very careful. We had to make sure that we were overstating what we had found. The result had been checked, cross-checked, and compared across different decay channels before we could confidently say that we had observed this particle. I represented the CMS results in 2012, and I was speaking on behalf of a very large team, if this answers your question. Looking back on the Higgs boson project, what would you say some of the biggest impacts with this discovery had on the physics community? The impact was enormous. The Higgs boson was one of the missing pieces of the standard model in particle physics. Finding it gave physicists strong experimental evidence that the Higgs field was real and that the mechanism connected it. But the discovery was not the end of the story. In some ways, it opened a new chapter in the field of physics. Once we had found the particle, the next question became, does it behave exactly the way that the standard model predicts, or does it show signs of something deeper? This is why this discovery matters so much. It confirmed a major theory, but it also gave physicists a new tool for searching for physics beyond the standard model. For students interested in nuclear physics or particle physics, the Higgs discovery is a great example of how theory, accelerators, detectors, and data analysis all came together with this beautiful discovery. This is the last question. Thank you for joining us for each of these. Could you tell us what was the most difficult part in discovering the Higgs boson? Well, the hardest part was proving that the signal was real. In particle physics, you were dealing with a huge amount of data and a lot of background events. And many ordinary processes can look similar to the signal that we're searching for. So the biggest challenge was not finding an interesting bump in the data. The challenge was showing that the bump that we had observed was significant and consistent across multiple channels. For CMS, two especially important channels were the decay into 2 photons and the decay into 4 leptons through 2 Z bosons. These channels gave us very clean information about the mass of the new particle, and the CERN courier described the CMS result as showing a clear excess above the expected background, which was part of what made the discovery announcement possible in the first place. So, patience, that was the most difficult part. We had to trust in our data and to show that it was in disputable of what we had discovered. And there you have it. Dr. Incandela, thank you very much for explaining your role in one of the most important physics discoveries of this modern era. Thank you, Taylor. This has been great. The Higgs boson discovery was a major moment in the world and in physics. But what I hope that people remember is that science works through careful testing. A theory may be beautiful, but in physics, we still have to go in and out to prove what evidence we have. This is what made this project so meaningful, and I'm grateful to have been part of the discovery, and I'm looking forward to what is presented in the future. So again, thank you very much.